Alright, let's take a look at some examples like your project. Now, they're not exactly the same. I've moved the graph around a little bit, so make sure you apply this as an example to show you how to do the project and not exactly what the answer will be on the project, okay? It says to assume that you have a triangle JKL and it's in the first quadrant, so that means the entire thing is going to end up in the first quadrant, which is this section of the graph here, okay? With measure of angle K is our 90-degree angle, okay, and the triangle is a 45, 45, 90. So somewhere over here, and I'm just going to make a rough sketch. I know I need to go this direction. The reason I know I need to go that direction is because if I go the other direction, I'll end up in the second quadrant, and I need to stay in the first because that's what it said. Segment JK is one of the legs, so this is a leg in a 45, 45, 90. Here's my other leg. What are the coordinates of point L? So point L is over here somewhere, and this is just a rough sketch. That's not my answer. How would I find the answer? Well, in a 45, 45, 90, we know that the legs are congruent. So if we know the length of this leg, we can use it to find the length of this leg. Well, this leg, if we just count the squares, is 1, 2, 3, 4 long. So our other leg, since it's a 45, 45, 90, should also be 1, 2, 3, 4 long, which would put L right there. And then I'm going to solidify my triangle here. Where would L be located then? Well, it should be 4 to the right of 2, 1. It's at 1, 2, 3, 4, 5, 6, comma, 1. So L would be located at 6, 1 if we are using it to create a 45, 45, 90 triangle in the first quadrant. Similar question. Something has changed though. Okay, so in question number 2, we still have a triangle we want to make in the first quadrant. We still want K to be the right angle, but this time it's a 30, 60, 90. Specifically, it says segment JK is the side opposite the 60-degree angle. So I'm going to sketch a triangle here. This is not my answer. It's just a set sketch so I can look at it. JK was supposed to be opposite the 60-degree angle. Okay, so my L is going to be down here somewhere. So what that does for me is it tells me whether I have the long leg or the short leg, because remember 30, 60, 90s have two different length legs and then a hypotenuse over here. Alright, we need to find out what the length of the short leg is so we know how far to put L away from K. Here's my short leg. I look in my formulas for 30, 60, 90 triangles, and it should say that the short leg is the long leg divided by the square root of 3. Now I have the long leg and I can count its length. It's still 1, 2, 3, 4 in length. So my short leg should be 4 divided by the square root of 3. So I just take my calculator and I do that. So I get that the short leg is 2.3. Okay, so where would that put L? It needs to be 1, 2, and then 0.3 away. So it's going to be about right there. And I can go ahead and draw in my triangle better. So here's my triangle. What would be the exact location of L? Well, K was at 2, 1. So I haven't gone up or down, so I know it's something 1. It's 2.3 to the right of this. So 2 plus 2.3 puts me at 4.3. So the location of L in this case would be at 4.31. So it's important to know which type of triangle you're working with, because notice we got completely different answers for the two, depending on whether we were using a 30, 60, 90 or a 45, 45, 90.